Earlier we talked about perfect square trinomials, and we knew that if we had something that looked like this, a squared plus 2ab plus b squared, this is what was called a perfect square trinomial. And so it means that it is a perfect square, and it evens out where you can actually factor it as ab squared. So what completing the square is it's working with the information that we know from that to create something as a perfect square without, and the way that we do this in real problems is you can always add something to an equation as long as you add it to both sides of the equation. So if we want something to be factorable and to be factored more easily, we can complete the square. So, so that it factors and it makes it more simple and easy to simplify. So there's some other uses for it as well. So anyway, so with completing the square, what we're doing is we're going to be asked to find the third term in a quadratic. So, so for instance, if I have, so you're going to be finding what, find C that will make the expression a perfect square. And we want it to be this, so it's going to be in the form of x squared plus bx plus c. Find C that will make this expression a perfect square. Okay, so we're going to go through the steps that you do this, and then we'll go through some examples. So the first step is to find half of b. Okay, now remember b is this coefficient of your x term. So it is just the number that goes with the x term. Find half of that. Then you're going to take that value and you're going to square it. Once you square that value, that is your c, and it's what you add in place of the c value to make it a perfect square, to complete it. So let's do an example. Close this. All right, so we have, if I want to find for x squared plus 10x equals c, or plus c, sorry. That's plus c. Find c. That's a perfect square. Yeah, make sure we know, because any c, you'd have to have an equal sign to follow this, right? But we want to know to find c to make a perfect square. Okay, so make it perfect square. Sorry, I should write this ahead. This one is, that's why I don't usually write it, as it takes forever to write with this. Okay, so the first thing we're going to do is we're going to take your b value, which is 10, and we're going to take half of it. So 1/2 of 10 is 5. And then we're going to square this. So then we're going to take 5 squared is 25, and that is what your c value equals. So to make this a perfect square, it would be x squared plus 10x plus 25. So now let's look at it in terms of what we looked at before with the perfect square here. This is a perfect square, x squared. This is a perfect square. And this is double the sum of 1 and 5, because this as a perfect square is 5 squared. So we can factor this as x plus 5 squared. Okay, so we've created a perfect square situation where we can factor it into something more simple and basic. Okay, so let's look at another example. Now on this, I'm not going to do another example of this one. You'll get lots of practice doing this. There's a worksheet that you'll go through and do. But what happens now if this value is not 1? So when we're completing the square, now I've been taught, there's a couple different ways to do this. So you can take the 2 out before or after. So I'm going to show you 2 different ways to do this problem. The first way is to go ahead and take it, take the 2 out first. So, I'm sorry. So we're going to take a 2 out of here, and so that we're dealing with just 2x minus 7x plus c. So I factored that 2 out. Then I can go through the steps that I have here, and I can keep my 2 on the outside. I can take 2x minus 7x, and I'm going to take this b value, and I'm going to take half of it. So 1/2 of negative 7 is negative 3.5. And negative 3.5, and then we're going to square it. And that's going to give us our, I think it's like 12.25, which is fine. It doesn't matter for sure. I'm going to actually write it though as, and what happens is when you square this value, it always becomes positive. So I'm going to go ahead and just call this 3.5 squared because we're going to factor it right here. So now, because of this, this is 2 times x minus 3.5 squared. Okay, just using that same process for factoring. Okay, so that is one way to do it. The other way to do it, so this is our first example, and then our second example is you can go through the process first. You go ahead and take your b value and divide it by 2. So negative 14 divided by 2 gives us negative 7, and then you're going to square your value, and you get a 49. Okay. Now when we go through this, when you put it in here, you get 2x squared minus 14x plus 49. But you can't use this unless these coefficients of a and b are 1. So if it's a variable. So what we're going to end up having to do is then here we factor out a 2. So it's just factoring out the 2 at different times. So that would be 7x. And then here you would get the 20, it's like 24.5. And then here we would have 2 times x, and then the square root of the 24.5 is 3.5. So we'll go through here. I'll see, and I might have done, so this one here, sorry, right here, so then this comes over and you get minus 3.5 squared. And that is the same answer we got in the first way we did it. Okay, so basically you cannot use this factoring process until you factor out any common factors out of it. That's a lot of factors written in that sentence, but hopefully that makes a little sense. Okay, so we'll go ahead and bring any questions you have to class on that. Sometimes completing the square, it seems a lot more complex than it is. It's something that, yeah, hopefully we'll get the hang of as we do more. So there's a couple ways that we look at data in statistics, and these are just 2 very basic ways we'll go over really quickly. There's the line graph, bar graph, sorry. We're going to start with the bar graph and then we'll do the line graph. So this is just where you represent values. So if I have slices of pizza here, and I have people here, let's say Ben has 4 slices of pizza, I'd represent that with a bar that goes up to 4. Kate has 1 piece, and Blake has 2.5. And you can create bars to represent how much pizza. Okay, so then a line graph is slightly different, where you'd say, okay, let's do 2 graphs, two values on each end as well. Sorry, not 2 graphs, just each axis has something. We say, okay, at 8 in the morning it was 20 degrees, and then by 9 it was 25, by 10 it was up to 40, and 11 o'clock we're at 50 degrees. And that would be a line graph. So we'll look at some examples of those, and you'll have a chance to read those graphs and create those graphs for different changes in in things represented by bar graphs and line graphs.